Hi, my name is Adam Andrus, and today I will show you how to make your first assembly in SolidWorks. SolidWorks is not only a great tool for modeling singular parts, but also for assembling them in a 3D space. SolidWorks can construct any assembly through its interactive features between parts that allow for specified motions. This is great for seeing how parts fit together before making them, and is also widely used throughout the engineering industry today. This is a simple tutorial on how to make your first assembly, which will be a simple gearbox. First thing you want to do is open SolidWorks to begin creating the gear parts that will go into the gearbox. Once you are in the SolidWorks homepage, you can click a new part. And now, once the Part Design Studio opens up, you can click Sketch and begin sketching on a plane. I suggest the front plane for a gear. You can select any plane really for this part, but I will always start with front plane on a gear like this. Now we can create a circle to begin our gear by using the center circle tool, and we can specify the radius down here to be 1 inch by just pressing 1 and hitting enter. And now we can dimension that so it will not move while we are designing the rest of our gear. Once we have dimensioned it, we can unclick the dimension and click a line to begin creating the teeth for our gear. We can go up 0.2 inches and enter. Once we do that, we can go ahead. For me to get rid of this line, I have to click like that and end it, because if I hit escape, it will end my current recording. But normally you can just click escape and it will end your line right there. But now I can hit X and then go ahead and select these lines and delete them. Once we are here, we can go ahead and dimension this just like that. And now once we have done our vertical line to get our height of our tooth, we can then get our width by doing a simple line like this. That will be, let me go ahead and get rid of that line and delete these two little lines on mine. 1 second. Just like this. Okay. Once we have that, we can go ahead and dimension that width to be 0.08. Click check. Now we can unclick our dimension, click our arc, and go ahead and make a 3-point arc between that width line and this height, and then put our arc center really wherever. We will dimension that in a little bit. Now, once we've done this, we can utilize a feature called mirror entities to mirror this sketch so you do not have to do it to the other side. So to do this, all you have to do is, when you have the entities to mirror box selected, you select the lines that you want to mirror. So in this case, it would be the curved part of the tooth and this straight width line right here. Now once we have that, we have what we want to mirror about, and this is simply the axis that the lines will be mirrored around. So we can go ahead and click that center axis right there and click check. Once we have done that, we can go ahead and dimension our center to be 0.0, sorry, 1, 5. Click check. And now, in order to get, we can unselect the dimension. And in order to get this to all be one seamless part between the circle and the tooth, we need to first right click that center line and click this icon right here, which will change it to construction geometry, which is lines that are used to dimension or add relations that make a sketch defined but aren't necessarily needed in the shape of the part. So you go here and do this, and that will take away that region right there. As we will also need to make this line right here construction, and this other width line right here construction. Once we have done that, we can take the trim tool. I like using the power trim, which is basically just a line like that you can drag by left clicking your mouse, and it will drag lines like that. And wherever it intersects, it will delete. So we go right here, and it will delete that curved part. And this right here will delete that curved part. Now you see here, this is now undefined, and that is due to the curved part being missing, and so the sketch can simply move around, such as that. To redo that, we can just re-intersect them. And we can check. As you can see here, the sketch can move around up and down. We really do not want that, so we need to go ahead and dimension the center point, which will be the radius as we had done before. So we can just make it 1 inch, and now our gear is defined. And in order to make multiple teeth, we can unclick our dimension and click this drop down to get to circular sketch pattern. And on circular sketch pattern, we can select the entities we want to pattern, which would be these. As you can see, they will pattern around as many times as you select right here. So we can go ahead and put, let's see how many will take to fill the gear. 20. Teeth will be appropriate for this gear, although other gears of bigger size or smaller size will have different numbers of teeth. But once you get here with your circular sketch pattern, you can go ahead and click check, and you will have all of these now sketched out for you. And all you have to do is come here and trim this piece right there, all the way around. Once you have this, you can go ahead and click check on trim. And now, just like the square or cube in the previous video, we can extrude this gear 1 inch as appropriate for a gear this size. 1 inch is about, well, yeah, 1 inch is about right. So go ahead and check. And that makes a fairly thick gear, but it will work for our current assembly. Now, one thing not to forget on a gear like this, or on a gear, any gear, is the center part where the gear will rotate about. Add that in now, we can click on that drop down right there underneath the extrude and select the sketch that we just made for this gear and click this icon right here that allows us to edit the sketch again. Once we do that, we can come in here and add a circle to the center, which will then add a hole through the center of the gear that we can then mount the gear onto a shaft. we can make this hole an 1/8 inch in radius, a 1/4 inch therefore in diameter, which we can dimension. Always remember to dimension your parts and make sure everything is defined, which leads to much less headaches down the road with parts moving around or sketches not acting as they should. Once we are here, we can see that we have made a gear. And now we will save this gear. We can come down here to the drop down, click Save As. And we can save it as Gear 1 or Tutorial Gear. Click Save. Now we have saved our gear. And we can go ahead and click right here, or sorry, click the home, so make another part. The next part we'll need to make is the fixture that will hold these gears. Now we can click the part to make a new part, and click on Sketch to go ahead and make the first part of the fixture. This first part will just be a simple rectangle that can then hold the gears together. Once we have created this rectangle here, we can go ahead and dimension it. Let's say it is 3 inches wide by 0.3 inches tall. Now, once we have properly dimensioned our rectangle, we can extrude it. We will extrude it 1/4 inch, as shown here. And now we can go ahead and begin our sketch for these shafts. Now this sketch will actually be on the face of this plane instead of on the face of this part instead of on a plane. This is because we want to extrude from this face instead of from this plane back here. This works just as any other sketch on any other plane. It's just that once you select it like this, you are now drawing on the face of this rectangle instead of on the plane that's back there. Once we are here, we can go ahead and begin our lines that will make sure that our circles are centered on this rectangle and the proper distance apart. So we can go ahead and select that midpoint there to there, and from there to there, and there out to there. Now we can add our circles to the ends of these lines, these longer horizontally outstretched lines on this end and correspondingly on this end. Once we have our circles made, we can dimension them to be a 1/4 inch, which is the same as the inside of the gears that we made earlier. And a 1/4 inch here. Now with those properly dimensioned, we can go ahead and dimension these lines, which will determine how far apart the gears are. Now if the gears are perfectly smooth, they would have a radius of 1 inch. So they would need to be 2 inches apart for them to be perfectly touching. Our gears have teeth on them that are 0.2 inches tall, but are meshed together. So they will need to be 2.2 inches apart. These lines are split, so they will each need to be 1.1 inches in order to, in overall, be 2.2 inches apart. 1.1 and 1.1. Just like that, we have our shaft sketch properly made, and we can go ahead and right click on these lines and make them construction geometry, just so that they don't interfere with our extrusion of our shafts. So once we have properly made them into construction geometry, we can go to features, extrude them. Now our gears are extruded 1 inch, so we'll need these shafts to be just a little longer, so we can extrude them 1.25 inches. And that will make them pretty much long enough for our demonstration. Once we have done this, we can go ahead and save this as well. And we can save it as our tutorial fixture. Now, with all of our parts made, we can go ahead and create an assembly. From here, you can just come right up here and click this drop down near the new icon next to the home. And this, at the very end of this list, is make assembly from part/assembly. So that means that it will make an assembly starting with this part. Now we want to start with the fixture so that we can then add in our gears and their corresponding relations that will make them work. So we go ahead and click on that, and now I'll open an assembly where we can go ahead and have our tutorial fixture selected and just click, and it will appear here. And once we're here, you can see it has been inserted into the assembly, and here are all of our assembly tools, beginning with the basic inserting your components, mating them together, different patterns you can make with them, different fasteners, so bolts, moving components in the assembly, showing so you can hide them, hide certain ones you don't want to see, then or show some certain ones you want to see, some geometry referencing, and some other things with simulations. What we will focus on the mates and the inserting components. So once we have this inserted, you can see here there is a F near or next to our part name, and that means that the part is fixed in place and it cannot move. So if I try to move it, you can see here it says the selected component is fixed, and that is what we want because we do not want this fixture to be moving around while our gears are spinning. So now we can go here to insert components, and we can click tutorial gear, and it will bring it into the assembly. Once here, we can go ahead and begin mating our parts together. To do that, we'll select the mate option under the assembly tab and have our first mate be between this face and this face so that they will be touching. So we can go ahead and select that face and then select that face. And as you can see here, they are under the coincident mate type, which just means that they are coincidentally touching like that. We can also select that they are parallel, which would make it to where this part will go in a straight line according to this face, or we can do perpendicular, which will make it perpendicular to that face, or lock, which will lock the geometry between them. But we want to do coincident in this situation because we want the faces to be touching. So now we can click check and then move on to the center bore, where we can click on the inside of this gear and on the outside of the shaft. Now this relation is concentric, which means that this circle and this circle have the same center and will spin around each other, but are not locked onto each other. So they can still spin, but will maintain their centers together. So we can click check. And once we have this, we can click X on the mate. And we have a gear that spins on its shaft of the fixture that we made. Now we can go to insert components again and insert another gear. Click there. And do the same thing with this gear. So we go ahead and mate that face to this face and click check. And then in order to get this gear to be apart from that gear, we can click X on that and just click this gear and drag it out so that we can see the center part right here. And we can click Mate, click that center, and click that shaft, and then click check for it to be concentric. But now you can see that we have this gearbox made, but the gears do not touch. They are not touching each other. They are spinning into each other, as you can see here. Actually, what we want is for them to actually touch and to be turning each other. To do that, there is a relation called gear relation, which is found under the mates and under mechanical. This relation requires that the gears be centered perfectly, though, so you need to come here to your axis, make sure you're looking at the front, and we can unclick the mate real fast, and make sure that your gears are centered like that to where they are not touching, because the mate will actually define the ratio between the gears, not that they are touching. So I will show you here. We go to mechanical, to gear, and we'll select the circles or the inner shaft circles of the gears to apply this ratio to them. So you select those. You can see down here, as long as the ratio is the same, so you can say this one could be 1 to 1 or 1/4 inch to 1/4 inch, it doesn't matter. As long as the ratio is the same, you can then click check and click X, and now the gears will turn together like that, as if they are contacting each other. And you can see this from many different views. You can study it up close and really just play around with how this mate works and how the Solidworks assembly works. It really is a very powerful tool to make these assemblies and see how everything fits together. As you can see here, from our dimensions and from our design of our parts, we were able to make this and check out that everything we designed worked properly. There's also many other drop down tabs here that deal with adding annotations right here, evaluating. So this is things with like measuring, aligning holes, the clearance of different parts. So you can look at the clearance between there and there, which on this part would be no clearance, and any interference between the parts. And sketch, you can sketch on anything, on any part here. Just as seen before, you can click a face, click sketch, you can go ahead and sketch on it. So then you can add in relations to anything else. I can just exit the sketch. And then here on layout, you can create several different layouts of how the parts are put together so that you can have different versions of the same assembly, but maybe there's different ways you can put it together. So this has been how to create a gearbox and assemble it in SolidWorks. I hope this was helpful to create your first assembly and see just how you can make something like this in SolidWorks for yourself. I would encourage to continue and play with this and play with the different aspects of the assembly. It doesn't matter if something messes up, you can always just delete it, delete the mate, delete the part if you need to, and re-put it back in. Really just play with it and just see what you can do with it. All right, thank you.